Okay, so in this presentation, we'll basically discuss how to get the frameworks and how to install them. So you already heard about them. Now we are giving you the details on where to get them and also some information on what might be the best path forward for you, depending on the system you're working on and what you need to get the right installation. So yeah, so in terms of what's supported from the AMD side, you know already a lot of this, but definitely TensorFlow, PyTorch, and JAX are the ones that tend to be more popular in the community, as well as Onyx and, for instance, DeepSpeed, and now you know about CuPy if you didn't before, HipPython, Flash Attention as well. And Brickle, which is the collective communication library that's what corresponds to Nickel, if you're familiar with NVIDIA. So for what concerns the porting of what might be your AI workflow on NVIDIA GPUs, porting to AMD is rather simple for the most popular frameworks. And in fact, for those, it's actually out of the box support. So if you have something that runs on NVIDIA with PyTorch, for instance, then you can just take that and run it on AMD GPUs with no changes. You're going to have to do a little bit more work to get it on comparable performance, but in terms of running, there's no extra work that you need to do. For what concerns kernel development with Triton, for instance, there's also drop-in support because Triton can leverage the ROCm backend when you are on AMD. But if you have anything that's custom with CUDA kernels, for instance, then we've talked extensively about how to port those to HIP yesterday. For what concerns some CUDA libraries that you may be using, you also know from yesterday that for most of them, we have an AMD equivalent. And something that we didn't discuss in detail, but is also worth mentioning, is the whole set of packages that are not from AMD, but support AMD, such as we mentioned Magma, but also the linear algebra solvers, such as Hyper or Petsy, that's not in this list. Eigen, Cocos also supports AMD. So those all support AMD, and you can use them to run on our GPUs. Okay, so in terms of what options you have to get these packages, in general, we have identified two that are the most popular, and going from simplest to set up to hardest, there's the container option, the pre-built wheel, or the build from source. And obviously, the ones that's the simplest comes with the least control and customization from the user. You basically get something that's already been packaged for you. And if that works for you, that's great. If you need more customization, then you need to move to the extra level. The wheel might be just enough customization for you. If not, then you'll have to go to the build from source. And that's what we normally use in our software offerings, let's say for events like this one, for instance, because we always try to supply the latest versions. And sometimes, as you've seen for CuPy, that's kind of a very emblematic example. The latest version might not be supported with the wheel. So the build from source is necessary in some cases. So yeah, so this is the ROCm GitHub, and it has forks of most of the packages that you have seen right now, and you already know about the one for CuPy, but there's one for TensorFlow, one for Triton, for instance, and so on. Okay, so for what concerns how to leverage containers, here we are talking about Docker, which is arguably the most popular. However, for some systems, Docker is not the best option because it requires sudo, and therefore you may encounter Podman, for instance, which is intended to be a drop-in replacement for Docker that doesn't need sudo, as well as Obtainer or Singularity. And if you want to get the framework with a container, basically you'll download an image, a Docker image that's been already built for you, assembled for you. You just need to run it with Docker, and you'll do Docker run, followed by a set of options. So for instance, -it will be interactive. Excuse me, with the -- device, you are pointing the image to the drivers for the GPU. You're gonna add yourself to the video group so that you can access the GPU. And then there's a couple ones that handle the security. And at the end, you specify the image that you want to run, and you'll run it basically. So this is probably the simplest, although you have to be in a system that allows the use of containers, because not all do. And also you have to make sure that the image you're running is exactly what you need. Next up is the wheel. If you are using the wheel, excuse me, you have to make sure that the GPU drivers are installed and that the ROCm and Python versions that you have in your system actually match the ones that the wheel has been built for. So, excuse me, is there a question? If there is, just, speak up and we can talk. But for what concerns the example of PyTorch, for instance, if you want to get a wheel, you'll go to their website and kind of like select from the menu, and eventually it'll get you a command with pip install that you can run to get what you need. For instance, here we're selecting pip, Python, and ROCm. This is an older screenshot now. There's higher versions of ROCm, but if you select all those, then it will output exactly the command that you need to run to get your wheel. So yeah, so an example of that is here for PyTorch. Notice, to be consistent with what I said before, that we are specifying the installation directory with this -t, which would be the target for the installation, just so that we can always keep our Python path clean and avoid situations where a Python package doesn't like the version of another Python package, and then you get a conflict. Nobody wants that. Yeah, so we run the pip install, and then we do this check here. So we run Python to check that the import of the torch module is successful. And notice that as we do that, we are also including our installation path into the Python path. Another option is the use of virtual environments, which a lot of people like because they make easier handling the paths, for instance. So you can do that with Python, and then specify the VM as the module. And then basically the procedure is the same. You just do it inside the virtual environment instead. And the virtual environments are a good option, though if you are in a system that has a lot of users, if everybody installs everything in their virtual environment, then it's not the best practice. But if you're just doing it on your workstation, for instance, then that's perfectly fine. There's also the option to use Conda, which adds the package manager functionality to the virtual environment. And the procedure is pretty much similar. It's just that now you will work in a Conda environment rather than the virtual environment, basically. And yeah, the good thing about these environments is that you don't have to worry about the Python path that is handled for you by the environment. So you don't have to worry about keeping it clean, or sometimes some dependencies are already there. So you don't have to install them. So there are some pluses to this, definitely. For TensorFlow, it's similar, so you can go shop on their website for a wheel. By their website, I mean the pypy.org website. And notice that the wheels here, unlike PyTorch, have ROCm specifically in their name. So it'll be TensorFlow-ROCm. And yeah, with TensorFlow is basically the same procedure with pip and the wheel. And for JAX, if you're trying to install the one from the ROCm fork, you have to be a little careful because you actually will need more than just one wheel. And that is because JAX is built in a way that you have the JAX module, and then you have the C++ library JAX lib, which is what's used to communicate with GPU. So if you're installing JAX, you'll have to install the JAX lib wheel, the JAX wheel, and then in the latest versions, you'll also have the ROCm plugin to make sure that everything is working. This this here is a PyTorch from source install. So this is kind of like a simplified version, I would say, because um, if you, well, so yeah, so this is done inside a container. But if you want to see something that's a lot more detailed and complete, then we suggest you check out our script in the HPC training doc. Here, it's using the CI build to install PyTorch, which is not something that we're currently doing. But this is just an example of how a PyTorch build from source might look like. See, there's like, you are specifying the architecture for the target, so you're not building it for all the possible architectures. So hopefully that will make it go faster. And yeah. Yeah, so for TensorFlow, it's kind of similar what we're showing here. We also have a script in our repo for that. So, you can get more details, I think, if you just check out our script. But the thing to keep in mind when you're building TensorFlow from source is that it's using this Bazel build system, which is a bit of an experience every time. So if you haven't used it already, just be aware that that's what it needs. Um, Okay, so a brief mention of the Recall plugin. So some sites such as Lumi and Frontier directly attach the GPU, the Instinct GPUs that they have to the Cray Slingshot network. So those are systems that are managed by HPE. And the good thing about this connection is that it enables collective computations on the device, and it minimizes the role of the CPU in this communication. Um, so basically, the main takeaway from this slide is that the CXI plugin is a runtime dependency and requires the Leap Fabric implementation from HPE Cray. And this plugin is not in the official Docker Hub images, so you have to make sure that it exists, and do something like what we're doing here to do that. Okay, so the next couple of slides show you an install of a Horobot and DeepSpeed. These two are just meant to positively scare you in terms of the positive part is to make you aware of all the environment variables that you might need to enable ROCm support. And the scare is because there's quite a bit that you need to include. So here you see we are specifying that the GPU will need to use ROCm. We're specifying the GPU target, the recall path. So there's some tuning that needs to be done, but remember that this is the build from source. So if you get to this point, it means that you want this level of tuning, so it shouldn't be too scary. And for DeepSpeed, you kind of have the same level of detail here that's available for you in terms of all these environment variables that you can specify before you build. Yeah, so this is a PyTorch example that I'm not gonna go over, but if you go in our repo for the examples and check out the ML examples directory, then this is where you'll find it. Yeah, so this is all for this presentation. The AI packages grocery store presentation. Are there any questions?
Can you pop up the slide which shows the many Linux repository where there's a lot more options?
Oh, great idea. Actually, I'll maybe just pop it here.
Yeah.
Thanks. That's a very good point.
So if you go to the PyTorch site, they're not going to give you as many options. And if you go to ROCm Many Linux, they're going to give you a lot more options of ROCm versions, more current. So we found that that was really important.
Yeah, so if you go down here, you'll find several packages. So there's like TensorFlow. You see, you can select the Python version that you need. There's PyTorch. There should be also Triton. Yeah, Triton here. Torch Vision, Torch Audio. And in fact, in some of our scripts, Jax, so you see Jax here has the plugin. In some of our scripts, we also supply the option to use a wheel, and this website is basically the place we pull the wheel from.
So you will see modules for a lot of these packages on the AAC6 system when you do a module avail. Most of those are built from source, and we get this question, why do you build from source? Well, we are customizing it for the hardware, pulling in GPU-aware MPI. And if you're worried about performance and using it a lot, that is a tremendous advantage. They do this at Lumi, where they build it over Slingshot because they're scaling up to hundreds of GPUs for their some of their applications they're running. If I were to run it only once, I would use a wheel, but if I'm going to run it all the time, I'm going to customize it. Any questions on that? Is anybody using some of these AI frameworks currently?
People in our group are, usually students doing little projects on their laptops. I don't know if anybody's using anything on a flip. No? So, yes, at least. Yeah.
They're coming, you know that.
Yeah.
AI is definitely got a lot of momentum right now.
Whether we
Also-
like it or not.
There's also a big push to use some of this in what we call AI for science, and so that's an emerging area. So I think we're going to see it on the clusters a little bit more than we have in the past. Okay, we posted some slide decks from a recent training we did on AI that was four half days in Europe. And it has a lot more detail on running AI workloads if you're interested in doing that. Or seeing what you have to do for your cluster and how to support it. And we're a little bit ahead of schedule. Do we want to run some exercises or go on to the next talk?